Hi guys, and welcome to this next video for Paper 3, Unit 6.2, Environmental Problems. So in this video, we'll be having a look at the impact of global flows on the environment. You need to watch this video in conjunction with the departmental website. So for this example of the environmental impacts of global flows, we will be concentrating on shipping. This video will focus on the negative effects of shipping, but also you must consider this imbalance. Shipping, and particular containerization, is very efficient. Therefore, the carbon footprint is comparatively small for any product that is transported by large container ships. This also feeds into the idea of food miles or product miles. Just because a product has been transported a long distance in physical miles or kilometers doesn't necessarily mean this is the worst environmental option. For those people living in Hong Kong, you should be aware that the shipping industry in Hong Kong as a major harbour does have a major effect on our pollution, on our air. In fact, on many occasions, the majority of the air pollution that we breathe in, 60% plus, can be attributed to the shipping industry. So we'll take a quick look at this video, which, bearing in mind, is a video from the shipping industry itself. So while you watch this video and make notes, do remember that there might be an element of bias.
I would be very concerned if anybody had a perception that the marine industry was not seriously concerned with its environmental performance, because that is really not the case. And there are many examples that we can point to that demonstrate that. There's no comparison with the efficiency of shipping, which carries more than 90% of global trade, in comparison to other modes of transportation. We are far more efficient than trucking, than rail, and many, many more times efficient than air freight.
Okay, so we've already considered the example where if you're transporting, for example, a television or a pair of jeans in a truck across a country, the carbon footprint of its transportation can actually be considerably larger than bringing that product from the other side of the world on a very large container ship. So there's something there for you to consider. Quite often, the largest carbon footprint from transportation occurs when the product is taken off the boat, which has been sailing from the other side of the world, and put onto a lorry and then taken to the distribution centre and then to the shop. So that journey might only be 60 or 70 kilometres, a very, very short journey. The actual carbon footprint per unit will be larger than bringing it from the other side of the world. So just something to bear in mind here.
Well, there has been recognition over a number of years that the continued use of heavy fuels by the marine industry needed to change. The current legal requirement for sulfur in marine fuel is 3.5%. By 2015, effectively, we're going to be down to 0.1% of sulfur in our marine fuels. And indeed, on a global basis, under the protocols that have now been agreed, the maximum sulfur content in fuel anywhere in the world will be 0.5%. So this is a huge decrease in the sulfur level within fuel. And
okay, so from the previous video, you remember preventing acid deposition. We talk about the desulfurization of fuel. So there he's talking about originally the fuels were very heavy. What they mean by that in the marine industry is they had a high level of sulfur. So now through the process of desulfurization, they've actually substantially reduced the amount of sulfur that's in the fuel. That is quite a considerable achievement. It did require international agreements, and it did require an element of regulation by the industry itself. So in itself, legally, as well as technically, that's quite a significant step forward for the marine transportation industry.
And obviously there's going to be huge benefits for the world overall. Despite the fact that the marine industry will continue to grow, our emissions will reduce considerably. The Energy Efficiency Operating Index is an attempt to formalize a lot of what you might call today standard practices. What will come out of the Energy Efficiency Operating Index is the most optimized manner of taking a ship from A to B. So issues of how much fuel we burn, what speed we make the voyage, at what draft and trim the ship shall be operating in different conditions. Weather routing will likely form a part of this, but also in terms of our environmental performance, just looking at the overall picture of how we optimize the ship that we have with the fuel that we burn for the most efficient performance.
Okay, so there we've got the concept there of working with cleaner fuels, but also increasing efficiency. So using computer models to work out the best and most efficient way to run the ship.
Traditionally, ships have exchanged ballast water in mid-ocean as a means of avoiding the importation of invasive species. But everybody recognizes that that's probably a temporary fix. And so the Ballast Water Convention that has been initiated by the International Maritime Organization will very shortly require all ships to have ballast water treatment systems physically fitted on board. As far as new ships are concerned, that will come into force in 2012. But by
Okay, if you're not sure what ballast water is the water that a ship takes into its hull to stabilize it. If you didn't have that, the ship would actually turn over. The heavier your load on your ship, the less ballast water that you need. So there is a case of pumping ballast water in and out. Now, originally, what they used to do is they used to take on ballast water. But of course, the risk of that is you're taking on microorganisms and all sorts of flora and fauna. And then if you release that into a totally different marine ecosystem, that's going to cause a problem. So to reduce the effects of that, originally what they did is they dumped that ballast water at deep sea. Now the industry no longer does that. And through a process of international laws and self-regulation, they actually filter that ballast water out.
By 2018, all ships will actually have to have ballast water treatment systems fitted. So you may also do a mid-ocean ballast water exchange. However, you will have to treat ballast water in addition to that.
It's obvious that being at Deltaport, we live in probably one of the most beautiful places in the world, and the environment is something that we take very seriously. Personally, I'm part of a DCLC third berth expansion committee that deals with concerns of the citizens that live locally around us, and we meet to work with them to make sure.
Okay, so you need to watch this video in conjunction with the departmental website. There's some wiki information. I did get it from wiki, so I'm being very clear where I got this information from. So it talks about ballast water, also talks about sound pollution, which is not a good thing for animals like Flipper, the dolphin. Let's have a quick look at this video from France 24.
Welcome to the Moscow Maersk, a giant on the open seas. It's as long as 4 football fields, wider than an 8-lane highway, and it's taller than Paris's Notre Dame Cathedral. It's one of the largest cargo ships in the world. And the company says it's also ecological. It's part of the Triple E fleet, designed to reduce both fuel consumption and CO2 emissions by up to 35% per container. a high-tech propulsion system combined with low-tech sailing. This Tripoli slow steams. The captain sets course at just 19.5 knots per hour.
If you are going very slow, you use the least fuel. It's the same when you are running. If you are running very fast, you get sweaty, and after 2 kilometers you cannot go anymore. If you are walking slowly, you can, after 2 kilometers, you can do maybe 4 kilometers because you're not burning so much.
Slow steaming has become an industry norm. It burns less fuel, and that saves companies money. But it doesn't do much to help the environment. Maritime shipping generates some 3% of the world's CO2 emissions. Now that may not seem like a lot, but if shipping were a country, well, it would be the 6th largest emitter in the world. Now the problem is that most cargo ships run on bunker fuel. It's cheap and it's dirty. It emits fine particles into the air, as well as nitrous oxide and sulfur. In fact, it contains 3,000 times the amount of sulfur that diesel does that's used for cars. Now, all of this, though, will soon be changing because in 2020, a cap on sulfur fuel will come into effect. It'll slash the current 3.5% down to 0.5%. And that's got the industry racing to catch up. To make the cut, some companies will simply change fuel and switch to a low sulfur oil. But it's more expensive. So is there a way to clean the dirty bunker fuel? Well, that's where scrubbers come in. Behind this wall lies 70 tons of equipment. It acts like a giant shower. Here we are in the so-called scrubber room. Tell us what this is.
Well, this is the room we built to house the main scrubber units, where the exhaust gas from the main engine will come up, and inside here there will be generated a water mist. The water mist will mix with the exhaust gas, and especially mix with the sulfur dioxide in the exhaust gas, and thereby clean it out from the exhaust gas. So the exhaust gas that leaves after the washing will be virtually free of the sulfur dioxide.
Okay, so there again, we can talk about the larger ships. They are more efficient. The going slow increases the efficiency and a cleaner fuel. So you can go for the cleaner fuel, which is desulfurized and is more expensive, or you can go through this process of desulfurization, which is the same process that we saw in the power stations. I just want to emphasize to you that this is a big step forward for the industry. It's a combination of international laws, national laws, and self-regulation by the industry. So as we said all along, the issue with transboundary, one of the issues with transboundary pollution is it's very hard to control and very hard to legislate against. So don't underestimate how difficult the legal process of doing this is. So as I said before, you need to have a read of this in conjunction with the department website. And so you've got a number of issues here that is associated with the shipping industry. Okay, in the next unit of work, in the next video, we're going to look at carbon footprints of global flows. We've already considered that the shipping industry has a comparatively tiny carbon footprint when compared to other forms of transportation.